To the first webinar that we're going to be holding for 2021. I hope you all had a good break and a nice rest, and you're all ready for another busy year for 2021, wherever you are in the country. Thank you for joining us today. As you can see, we're going to be talking about the new Sarah bar and Delta bar Evolution 2, the new generation of pressure devices here today. And we will also be using Menti later on throughout the online seminar. So if you want to set that up now, or I'll also be able to show you a few instructions later on. Now, just for those that are new to the GoToWebinar interface, I've got a bit of an explanation around what this will look like that you're looking at the moment. So you can change the webcam video or the window by just clicking or moving your window around, just like it would be for a normal program. But the more important things are on the right-hand side. So in the handout, I've got a handout around some of the safety information and the innovations for the new Sarah bar and Delta bar range of devices. And of course, throughout the webinar, you can also ask your questions. But if you want to do that, you just need to type in the question on the right-hand side of the pane, and we'll get to you at the end. You'll be able to control also your speaker and your volume and everything from that top right-hand side too. So a bit about myself. I'm Taylor McCurdick, and I'm the industry manager for mining, oil and gas here in Endress+Hauser, Australia. I'm based in the Sydney office. I've been with the company for about 3 years now, previously spending around 5 years at a large Australian mining company at several different operations in central Queensland. It's just me by myself today, but throughout the year, you'll see more webinars from some of our other industry managers as well. So for today, I'll be talking a bit around the history and the evolution of our pressure portfolio, some of the key benefits in the new innovations that come with the Sarah bar and Delta bar Evo 2 product range, including the improved heartbeat technology integration. I'll also give an example around a case study, and then I'll reserve some time at the end for some questions. So the history and innovations of pressure from Endress+Hauser. You can see since the innovation of the 1980s, where we had the first Delta pilot level probe, and we also utilized the ceramic measuring cell. When we transformed our range again in the 1990s with the addition of differential pressure measuring cell, and also incorporating the con-type measuring cell membrane, which is the condensation type one. And in the 2000s, we then incorporated a condensation resistant ceramic measuring cell. In the early 2010s, we introduced the Temp-C membrane and also integrated electronic DP into our portfolio. And finally, you can see during 2020, the new generation of Sarah bar and Delta bar that we'll speak about today. So I'm going to delve into some of the details around the new Sarah bar and Delta bar products right now. And you'll see that there's a lot of good innovations and pretty cool innovations that we've incorporated into our new products now. So just an overview for those that are really familiar with our old Sarah bar and Delta bar M and S classes. You can see on your left-hand side there, there's a bit of a simplification of the portfolio where there's several different components for the Sarah bar S and also M, which then simplify down to a few order codes, either PMP, which is your traditional metallic membrane, or the PMC, which is a ceramic membrane. And then the number differentiating between an M and an S class. I'll get into that a bit further. So we've really tried to simplify this first package of release, and you'll see over the next few years we'll be releasing a few additional packages with more innovations as well to come. We just want to also clarify some of the segmentation between the two different types. So if you're ever worried or wondering what that number means after the PM or this one here, PM7 or PM5. So the 5 is around, we're focusing on good performance compared to the cost ratio. We're including Bluetooth as well. It will have a wide integrated offering. We've developed it so that it has SIL capability, the CRC checksum, and self-monitoring ceramic membrane. That's all available with the PM5 series. And then with the 7 series, you get all the same benefits of the 5 series, but you get an improved measuring performance. You get a improved graphic display with a backlight and touch control, as you can see there. You get heartbeat technology, and also you get additional wizards. You get a Hysterom. I'll speak about that soon. You get that this is the device for more challenging applications where you might have high pressure, low temperature, cryogenic liquids, etc. Or you require special materials, you would utilize this device. And then it also gives additional chamber housing options, whether you have 1 or 2 chambers, or you can use aluminium or stainless steel housing options as well. So a bit of a summary around what's new. As I mentioned before, you've got heartbeat technology, Bluetooth connectivity, which you'll see with the rest of our level range, and our density range as well has Bluetooth. Now our pressure range has Bluetooth. Our ceramic measuring cell, which is suitable for vacuum applications, and it's also 99.9% pure, so which means it doesn't react with anything, and also reduces hydrogen diffusion. Display backlight. And then for all these additional other features that you might be a bit familiar around, it's ISO 17025 accredited, so that's related back to this, the quality control. Hysterom, we've developed it to ensure SIL 2 or 3 if applicable. We've got some wizards that I spoke about before. We've integrated a large range of additional options and integrated offerings such as manifolds and weather protection covers, etc. The CRC checksum, touch control, and also we've included a temperature compensated current output to achieve the highest accuracy. And speaking about accuracy, our portfolio now has an accuracy requirement for every application. So whether you want a cost-effective device with just standard accuracy, the PMX1 series, which is not part of the new Evo 2 area, all the way up to your Cerebar S, which is the PMX7, with the platinum accuracy package goes down to 0.025% accuracy, which isn't beat on the market. So whether you need really high accuracy or just cost-effective, a balance of performance and cost, we've got a large range for every application. So now I want to get you involved around and get your thoughts around the impacts of an incorrect or not well-functioning pressure device in your operation. So if you haven't already, you can grab your phone and use the code up here, so 5483528. And once you've logged on your phone, if you could answer this question, how long does it normally take to replace a failed pressure device in your plant, let's say on a back shift? So whether you're at night shift, you might have a skeleton crew, or you might have not very experienced operators, maybe they're replacing these failed pressure devices or something like that. How long does it take to replace one of those devices on your back shifts? So we'll just wait for some of the answers to come through. Looks like right now an average of around 90, 110 minutes. Okay, so almost 2 hours by the time I guess you get the device, you plug it in, you commission it, etc. We'll just wait for a few more minutes for everyone to add their answers. Okay. All right. Okay, so I think it's around, we're going to say around that 100 minutes mark. Okay, so around 100 minutes, an hour and a half or so it takes to replace your failed pressure device on like a back shift or something. Okay, let's remember that number. Now I want to ask you, has there ever been an electronics failure on site where a lid of a device hasn't been secured properly? So have you ever had the issue where there's maybe been moisture ingress or the device has failed? I'll give you a few more minutes to do that. Okay, so quite a few of you have answered already. Okay, looks like about 3/4 of you have experienced something like that before. Yep, for sure. It's quite a common problem. I want to ask another question as well now. How long does it take for you guys to commission a pressure transmitter? So you put it in, but how long does it take for you to set it up? How many minutes? Yep, so make sure you're got that Menti question up there. The details for Menti at the top if you haven't got it already. Looks like it'll be around 40 minutes. Okay, excellent. And second last question, how much does it cost for you and your operation to reach like a high, hard to access place when you need working at heights permit? How much does it cost? So we'll see some answers coming up on the screen there. How much would a typical working at heights pressure transmitter replacement job cost? Okay, so we've got $3,000. So include all the scaffolding cost, or maybe you need an EWP. Some of those other costs. Okay, so around got a few 5,500. About okay, so between 1,000, 5,000. Let's say around an average of about 2,500. It looks like, so it's not cheap. Okay, excellent, very good. And the final question. Oh, just lost it there. Okay, one last question. What's the cost of your plant if it had 1 hour of downtime caused by a non-operating critical sensor? So you said before that it took almost an hour and a half to replace one of these pressure transmitters. Let's say your plant is down for that one hour of that time. How much is it cost to your business? So we'll go, oh, quite an even split there. We'll just wait a few more seconds for that to roll through. Looks like a third of you said sometime between 50 and 100 grand. A third, okay, so I'm guessing it's an average of those three will probably be around the $50,000 mark, which is quite a significant amount of money. So we'll go through some of the features now around, I mentioned before Hysterom. So what the Hysterom is, it's the data backup of your device. So that means in the event that you have to replace the device, if you want to keep the same electronics data, then all you have to do is transfer the Hysterom from the old one to the new one, and then it's literally a plug and play. So if you can remember back to that first question where I asked you how long it takes on a back shift to replace a pressure transmitter that's not working, say for example at 3 o'clock at night, the solution is just to get a new device out of the warehouse, unscrew the old electronics, plug in this Hysterom from the old device, insert the new electronics, and then it can be directly used from the previous settings. So you won't have to do any other commissioning or anything. So really that will literally take 5 minutes. It's super easy, safe, and fast for your pressure transmitter to be swapped out in the event that it does fail. And you can see here a bit of a diagram on the right-hand side of the exploded view of a PMC 51 in this case. So you can see the Hysterom is just that small data unit there. So you'll see it in the electronics. So without any additional tooling, it's quite easy and fast to set up that device. In terms of the operating concept, so we've added a backlight and you can also use the device with optical sensors. I'll show you an example in a moment. This is one I've prepared earlier. You can't see the backlight on your screen because of the lighting in this room, but I can assure you that it is green. As you can see here, and then once there's an error with the device, then it will change to red. So you can easily identify which device is either out of spec or out of go alarm. Particularly useful for if you've got a large row of many devices or lots of devices in the same spot, you can easily identify which one has got the error, and therefore it saves you time when you're attending a breakdown. Also, another thing was you guys answered in the questions, about 3/4 of you mentioned that you found moisture in the device because the lid wasn't on properly. So with the 71, which you can see here, has optical. You can operate it using the optical buttons or the optical sensors, which means you don't ever have to open the lid to change the settings on the display itself, which is extra safe. And there's no real reason why you would want to open the lid during normal operation with the optical sensor buttons, or using Bluetooth as well, which we'll get into a bit later. So here's another picture of the device with a backlight, but you'd come to us because we've got a large integrated offering in our order structure. So you can get all these different manifolds and additional documentation, testing, procurement as well, and accessories. You can get it all from us. And really, it makes it much easier on your side, where it becomes just a plug and play rather than sourcing different manifolds, getting different gaskets, doing leakage detection when you're creating the assembly and everything like that. And of course, it always fits because we make it here all in one piece. And it will be easy and plug and play once it gets to your site. I mentioned very briefly before around some wizards and digital assistants. So as we know, as time goes on, there is a big skill shortage in our industry, and that means we need to make our devices easier and easier to use and set up. So we've introduced wizards. So there's a commissioning wizard, there's a seal locking wizard, we've got a seal repeat checking wizard, we've got some heartbeat functions. I'll talk a bit about that in the next slide. And in terms of an example of real value, then for example, if you're commissioning your pressure transmitter and your skilled engineers or technicians might not be familiar with a certain one, then they can just follow the wizard step by step and reduce commissioning time from around 10 minutes from our old device to just 2 minutes. In addition, the best thing is that no step is forgotten because you've got a structured user guidance. So you just go step by step and then it's done. So this example, you save per measuring point around 8 minutes of commissioning time. And as I mentioned before, we've got lots of wizards with this device. The commissioning wizard, which can be accessed via DTM, Bluetooth, or our tablet, SMT70. We've got proof test wizard for those that require the device to be proof tested. And we have a lot of diagnostics around the heartbeat technology wizards, which I'll speak about later. As I mentioned, you can go via DTM, so via heart loop or service CDI connectivity. So some of you asked in the questions before the webinar how to commission the device. So yeah, DTM remote, so via Bluetooth, so using your smartphone is fine, or a tablet that we have, or any other Windows tablet as well. Or of course, you can commission it also via the display, and the display will also offer the wizard. So if you ever need some support in your configuration, you just cover the E key, which is the one on the right-hand side, and it will bring up some of that as well. I mentioned very briefly around connecting your device wirelessly. So now it does have Bluetooth connectivity. So there's no need now to climb large ladders or access high risky or hazardous tanks or locations. You mentioned it cost around $2,500 to implement a working at heights permit to access or replace or commission or troubleshoot a device that's up in a high area. So this eliminates the that cost, and yeah, as you can see it there, around between $1,500 and $3,000 saved without having to access using an EWP or scaffolding. And you can access the device with Bluetooth wirelessly with a tablet or your smartphone quite easily. As you can imagine, that's going to be a lot of time saved. Here's an example of what the Bluetooth app looks like. And if you tuned into our previous Heartbeat webinar, you would have seen me doing a verification with my smartphone. And so you can check out our website if you want to see that webinar, or you can also ask us in the survey afterwards, and we'll get in touch and we can show you a few videos and things like that. Again, our tablet there, which can be easily commissioned with the device with our Bluetooth capability, and then of course your Windows PC with device care can also do the same. So there's lots of different options to wirelessly commission your device. And another question that does come up quite often is around the security of Bluetooth. So we've really worked hard to improve the security of our Bluetooth capability with our devices. So we use the PEG principle, which is the same principle, security principle that they use in Germany for their identity cards, which is similar to like our driver's license. So the password isn't stored on either side of the device, and we've also been third-party tested to determine where how secure our Bluetooth security is. And standard Bluetooth encryption is low, so like your mouse would be on your laptop, while our Bluetooth is high. So you can see it's been third-party tested. And both algorithms and protocol are being tested as high, which means an attacker would take months to hack that. So it's at a similar level of government security. All right, so in terms of the Sarah bar and Delta bar, for security and smart safety, really, it's around detecting things that are wrong with the device as well. So we've got automatic under voltage detection of the device. So you'll see the display turn red if that happens, and a few other heartbeat monitoring functions that I'll go on a bit later. Some time savings with around the seal locking and repeat checking, including the documentary tracing as well. So you save about 10 to 15 minutes per measuring point for following the wizards for the seal checking and repeat checking as well, and also eliminate that manual documentation. This is a bit of an overview of a cutaway of the device around some of the safety components. So we have a highest diagnostic coverage of over 95% of all the components in the device. We've got Bluetooth interface, which I mentioned before, eliminates those hazards on site, climbing to those hazardous areas in your plant. We've got secondary process barriers to ensure that the material doesn't go into the housing space. We've got membrane breakage detection technology, and also different membranes such as ceramic and Temp C to ensure that it doesn't break. The wizards I spoke about, heartbeat technology, the CRC, and then our sensor is improved accuracy and also much faster response time as well. So now I'm going to be going through a bit of an animation around heartbeat technology and what it means with the Sarah bar and Delta bar. So is it possible to check the condition and functionality of a pressure transmitter within 3 minutes? How about while the process is running? Well, the answer is yes. And with our new Sarah bar and Delta bar pressure devices, equipped with heartbeat technology, I'm going to show you how in this animation. So back in the olden days, the verification of 4 to 20 milliamp transmitters was quite a complex task. You had to access those measuring points, which are really hard to reach, and you could have additional sources of error when you had to open the housing covers and handling the terminals in the production area. And you had to search for the right terminal in the control cabinet. It took a long time, and if you made a mistake, then problems in the process could arise. So we secure those and meet those challenges with Bluetooth, as I explained before, and you can go up to 15-minute range, which is actually quite useful. So all you need is a mobile device and a Smart Blue app. And the big advantage of this app is the automatic updates. You can search for HART, EDA, or DTM libraries. That is a thing of a past. It automatically updates. All you have to do is type in your password, and it works quite well. Then after 15 seconds, you'll get an easy to read report with results of the test. The total test coverage is more than 95%. It also ensures that testing of the most important functions of the device. So this report can be archived as a PDF file, and it also helps any document compliance issues that you might have on site. If required, you can pass that document on to employees responsible for maintenance and production. The report contains the overall result of the verification of the correct functioning and valuable additional information, such as you can see on your screen, like terminal voltage and sensor temperature. Heartbeat technology and the new Cerebar and Delta Bar pressure gauges enable condition-based maintenance. Verification without process interruption is fast, easy to operate, and increases the productivity of your plant because it makes the control of planned revisions more efficient. So we have Heartbeat technology from Endress+Hauser for flow, level, liquid analysis, temperature, and now for pressure. Now we have a full portfolio of devices with Heartbeat technology. So Heartbeat technology. That was a bit of an introduction and animation around that, but it's really all about maximizing your productivity when you're in the plant. We've got guided verification throughout this process and monitoring functions for predictive maintenance, which I'll talk about a bit later. And this is around making sure that the measuring function is working while you're running your process. So you can reduce the frozen values in your plant that you might experience or plant downtime. And the cost savings on that does depend on your plant size and length of standstill, but from what you guys told me, it could be around as an average of $50,000 per hour in lost production. So Heartbeat technology can help save that amount of money, which is great. Some of the permanent diagnostics and standardized messages that come from Heartbeat technology. So you can see on the left-hand side there, continuously automatically checks the software, whether the sensor is integral, such as membrane integrity, under voltage, output currents, loop diagnostics. And you can see here the safe failure fraction of 91% for the PMD75 compared to the PMD75B is a safe failure fraction of 97%, so a significant improvement. In terms of verification, so the animation showed how easy it was to get a verification report, and I demonstrated that last webinar. But you can see here a report looks like this in PDF. You got your device information, verification, pass or fail results, and all the information around what it's testing and the result. Now, I spoke about heartbeat monitoring, and there's many interesting and exciting things that we can now monitor the device with Heartbeat technology. The first one is around the signal median and noise, and you can detect process anomalies with this. So for example, let's say you forget to open a valve after maintenance, then the device will detect this and it will give a alert through Heartbeat technology. You can also determine if there's plugged impulse lines with the Delta bar and Cerebar. Another example might be a flooding of a distillation column packing where you generate a lot of signal noise. So the Delta bar there. So lots of air bubbles or processes have gone out of control, then you'll be able to detect it with a device. Another thing is the loop diagnostics, so you can detect a change in loop resistance. So you can see here as the terminal voltage decreases across the baseline, let's say there might be water in the housing or you might have corroded terminals, then Heartbeat technology continuously monitoring the device will be able to determine if this is occurring and give an alert. Or if your power supply is deteriorating, like you get an under voltage, then that will be able to be also utilized so you can maximize the availability of your plant. And as I mentioned before, you can also detect your process failures within your plant. So things like water hammer, steam hammer, or pulsating flows that aren't supposed to be there. As you can see in this little graph here, the device will also be able to detect that with Heartbeat technology. So it's actually quite a powerful tool to optimize your process. So some of you might be asking, okay, so it looks like there's a lot of devices available. Which one is best for me? And it's actually very easy now to identify, first of all, which device is best for your application or industry. Also, what is the performance of my device? What is the error? And then finally, can I size the diaphragm seal with that? And all the answer is yes, you can with the new generation of devices. It's super easy to calculate your performance online as an example. So all you have to do is either scan that QR code or you can go to endress.com, and with 3 clicks, you'll be able to calculate that very straightforward. So if you have time after this webinar, go through the website. And if you'd like us to give you a bit more information about how to easily calculate the performance criteria of your device or how to select the right device for your application, just let us know after the webinar in the survey, and we'll get in touch with you guys there. Now I'm going to go through a case study. This device here was in an oil pipe. So we did a flow measurement and a pressure measurement as well. And some of the challenge there was around the closed valve or the plugged impulse line. And we managed to demonstrate with the devices that with heartbeat monitoring, you can actually detect that. So you can see here, we utilize a PMD75B and a PMP71B with heartbeat technology, which is the one that I had over here before, which is the differential pressure. This one here. And I'll just show you on the next slide as well, the signal noise. So the black line was the baseline that was recorded when the application was running in the normal steady state, which was the standard flow line. And the red lines were then calculated by the device algorithm to determine where the safe window of operation was from the steady state. This blue line here that peaks up in this location in the time and then peaks up on that location at the time, that was the signal noise, and that changes depending on the valve position. So at the beginning there, the valve at the minus side, so the minus DP side was closed, and it created a large amount of signal noise, which was detected by the device. And then when the valve at the plus side was closed, then a large amount of signal noise happened also there, and the device was able to detect that. So with heartbeat technology, this is some of the things that you can do. And obviously, a valve closed when it's not supposed to be is not a good thing to happen inside your plant. So an event was generated here and here with heartbeat technology, and the operator will be able to optimize their process to save that and manage that. So thank you everyone for paying attention for your webinar. Now, before you go, we will get into questions very shortly, but I just want you to make sure that you don't forget to fill out our survey and let us know your feedback or any questions. And of course, this is our first webinar for the year, but we've done quite a few last year, and we're going to keep doing them this year. And you can find all that information either on our website coming up, or we'll also send you some information as well through email. So what I'm going to do now is I'm just going to go through some of the questions that everyone has, and make sure if you do have a question, make sure you type it in the chat window on the right-hand side. Okay, so I'm just going to go through the questions now. I'll just give everyone a few more minutes to type them in. Okay, so I got one question around, is the device available for IO-Link? So the PMP and PMC 5171 isn't available in IO-Link at the moment, but we do have a different portfolio with IO-Link devices, so we can just get in touch with you around that. So that's around our previous generation of pressure devices. We've got a great question around the suitability of Bluetooth technology on hazardous areas. Yep, that's a good one. So utilizing our tablet, the SMT77, which is our EX-rated tablet, that also has Bluetooth technology, which means you can be able to communicate with the device as well through the SMT77. We've got another question as well. Is it available for hygienic applications? Yep, that is a good question. I would say if you require hygienic connections, we have a different portfolio range that we can let you know about a bit later on. But stay tuned, you'll see something come out in the next year or two, maybe. We've got another question here. What is the performance of the PMC 71B? Yep. That is, depending on what type of accuracy option you can get the premium option or the standard option. I think I went through that before around with the P71B, you can go all the way down to 0.025% accuracy. How long does it take to get a device, a PMP71B? Yep, that's a great question. The exact answer will vary depending on exactly where you are in Australia. I'm assuming you're in Australia. But we can just type in your name in the survey, and we'll get back to you for an exact lead time for where you are located. Okay. If anyone's got any more questions, just for reasons for time, we will get back to you after the webinar. But I just want to thank everyone for attending today, and thank you for your attention. And again, let us know your feedback. Let us know if you want us to cover any more topics. Or we can get in touch with you individually one-on-one and give you a bit more of a demonstration around the capabilities of the new Cerebar and Delta Bar Evo 2 devices.